When you desire to utilize your muscles, for instance, lift a weight, your brain sends a signal to the muscle in the form of a motor neuron. Muscles are made up of fascicles, which are bundles of hundreds of thousands of muscle fibers called myofibrils. Each myofibril is made up of a sarcomere. There are also these structures called troponin, which calcium binds to initiate the contraction. The sarcomere is made up of these thick fibers called myosin, which are located in the center, and thin fibers called actin located on either side of each myosin. In a relaxed muscle, the place for the myosin head to attach is blocked. When the signal is sent, the calcium channel opens, calcium binds to the troponin and floods into the sarcomere. This causes the actin fibers to rotate, revealing the spot for the myosin head to attach. When the myosin head attaches, it pulls the actin and the two filaments slide past each other. This is called the power stroke. After the power stroke, energy in the form of ATP is needed for the myosin head to detach from the actin fiber. After the ATP is used, it breaks down into ADP and organic phosphate. This enables the myosin head to grab another spot and repeat with the power stroke and detachment. When the process is over, calcium detaches from the troponin and leaves the sarcomere. The myosin and actin then slowly slide past each other in the opposite direction, and the muscle relaxes. It is important to note that neither the myosin nor the actin are getting shorter during the contraction. Rather, the sarcomere shortens because the space between each myosin is getting smaller as the actin and myosin slide past each other.
There are two theories of muscle growth. The first is called hyperplasia and the second is hypertrophy. Both begin the same way, with a torn muscle and satellite cells flocking to the torn area to help repair it. In hyperplasia, the satellite cells fill in the area and repair each individual half of the torn cells. These cells, in turn, make their own new cells. In hypertrophy, the halves are repaired and connect back to themselves, therefore making the same number of cells, just bigger and stronger. So, in hyperplasia, it's the same size cells, there are just more of them, and in hypertrophy, it's the same number of cells, they are just bigger and stronger.
The food you eat impact how our muscles work. Spinach is full of iron, which is a very important mineral for muscle building. Spinach is also rich in calcium, which has always been known to create strong bones. Calcium helps relax the muscle, thus reducing the chances for cramping. This causes better and greater muscle contractions that facilitate muscle growth. Beef is a major source of iron and zinc. These are two crucial muscle-building nutrients. It is the number one food source of creatine. The protein in eggs have the highest biological value, but you have to eat the yolk. In addition to protein, it also contains vitamin B12, which is necessary for fat breakdown and muscle contraction. Almonds are one of the best sources of vitamin E. Vitamin E is a potent antioxidant that can help prevent free radical damage after heavy workouts. Chocolate milk is one of the best things to drink after working out. It has the perfect sugar to protein ratio. It has double the carbohydrate and protein content, perfect for replenishing tired muscles. Its high water content replaces fluids lost during a workout, preventing dehydration. Plus, it packs a nutritional bonus of calcium and includes just a little sodium and sugar.
One question our group had can be demonstrated in these drawings. There's a guy who's lifting weights and he thinks to himself, why do my muscles feel sore? Well, here's the answer. Before working out, your muscle tissues look like this, beautiful, unrealistic straight lines. Then, during the exercise, these perfectly straight-lined muscle fibers tear. Then after the workout, your body repairs these tears with the help of satellite cells. Your muscles feel sore when the fibers are tearing and being repaired.
Another thing our group wondered about was twitching. Twitches are called fasciculations, which means they are minor, uncontrollable muscle contractions in a concentrated area. Much like the muscles of your heart, your intestines, and your diaphragm, twitches are involuntary. And twitches happen in a group of muscles served by one nerve. Most causes of twitching are benign, such as too much exercise, too much caffeine, too much junk food with not enough good nutrient-rich food in your diet, and, of course, as we all know, too much stress. Some causes, however, are more serious and can show damage to motor nerves. The reason we wondered about twitching was because it happens to everyone, and we wanted to know if it was good or bad.